Okay, so here we go. Because it is fall, the trees are continuously jizzing leaves all over my bench, so I'm just going to have to work around it. This happens every year. Anywho, here is lanthanum acetate. Focus, you piece of shit. I made this from a chunk of lanthanum metal. See that? It's very nice, very pretty. It's just a white solid. This is the hydrate, obviously. All I did was reacted lanthanum metal with hydrochloric acid. I then precipitated out the hydroxide, centrifuge that shit down to get rid of all of the sodium chloride because it absolutely refused to settle out on its own. I dissolved all of that and a little bit of excess acetic acid and then evaporated it down to get those nice white pretty crystals. Isn't it nice? It really is beautiful. I'm quite proud of it. So, anyway, man, I'll tell you what, like a couple of years ago, that actually would have been a challenge, and now it's just like, practice makes perfect. Getting lanthanides to make nice hydrate crystals and not oxidize takes a gentle touch, which I frequently lack. What we are going to do is take a solution of this that is chilling in a QT cup just because it actually fits the damn beaker. There is a solution of 3 grams of lanthanum acetate in here, and hopefully, yes, it's all still dissolved. A lot of what I am working with here is, I mean, this is all the procedure is based on what Atomistry says. Now, there is that other paper that I found which also mentioned this method, and they had, were doing it such that they wanted to actually, they were using this as an analytical method, and for all I know, this may be a standard analytical method for determination of acetate and fluoroacetate. I mean, it's supposed to produce a color, so I mean it would lend itself to spectrophotometric analysis, I would think. But anywho, we are not interested in actually doing useful work with this reaction. We just want to see pretty blue color. So, we are supposed to take this chilled solution of lanthanum acetate, which I will clean up here. Alright. Okay, can you see that? I hope. Alright. Now, according to Atomistry, we are supposed to add iodine dissolved in potassium iodide solution, which I have here, to this. Then we are supposed to add ammonia to this until almost all of the iodine is reacted, and then we are supposed to gently warm it. And this is supposed to be a quote-unquote convenient way of preparing this blue compound. Now, thanks to our lovely friends that wrote that paper in 1948, I know that chloride ion interferes with this, with the color formation. Now, that may only be relevant in the context of trying to do analysis with this. I mean, you would need to fully remove chloride if you wanted to actually get any useful analytical information out of the reaction. I don't know if the small amount of chloride that I'm sure is still in the lanthanum acetate, just from how I made it, will interfere or not. I don't know. I guess there's only one way to find out. So, here we go. As for stoichiometry, I mean, there's 3 grams of lanthanum acetate, what I presume is the trihydrate in here. I don't know. Lanthanum usually has a fairly high coordination number, but finding information on what kind of hydrate it actually makes has been difficult. I mean, a lot of lanthanides are non-coordinate. It seems strange. I mean, I don't know. Maybe it's because both oxygens and the acetate are coordinated to the lanthanum cation, and that makes 6. leaving only 3 spaces for water. But then I keep finding all this shit about lanthanum acetate monohydrate. I don't know. It's very confusing. Anywho, here we go. We're going to add some of this into here. We don't expect anything to happen at this point. It's fairly dilute, which is, from what I read, that's what we want it to be. Okay, now we are supposed to add this ammonia to it, and that is supposed to precipitate out the lanthanum acetate as basic lanthanum acetate, and it will form a blue absorption compound with the iodine. Here goes nothing. Okay, it did something. Doesn't really look blue. I'm not exactly sure how much I should add. Alright. And now we're supposed to gently warm this. So I will do that. And I'll come back when I have something to report. Okay, so you can see by the colors of the bubbles, I hope, that we're getting kind of a dark purple solution. Just to be sure that this is indeed something that is the lanthanum is involved with this, I combined some of the potassium triiodide solution with some of the ammonia, and this is what I got. You can see it is a very different color. It is this brown shit. I'm not 100% sure exactly what this is. I'll have to look up the reaction. I can't think off the top of my head exactly what it's doing. I don't know. Anywho, it doesn't really matter. What's important here is that this is an extremely different color from this. The whole point of this was to be able to see the, blue lanthanum acetate, quote-unquote. Really, the basic lanthanum acetate iodide absorption complex. And indeed, that is what we have here. Okay, what I did here was I transferred most of it to another beaker, and then there was a little bit left in the bottom, and I diluted it down a lot with water. And now you can finally see the blue color with the sun shining through it. It's easy to see that it is not a blue solution. At least it's easy to see IRL. I don't know how that's showing up on the it's showing up on the camera, but it is made up of little particles that are just kind of suspended in the water. I presume that is the absorption complex between the iodine and the basic lanthanum acetate. But you can actually see the color. It's not just some overwhelmingly black liquid. That is so fucking cool. Look at that. That is fucking beautiful, man. Obscure shit on Atomistry is so fun. That is so great. Yeah, well, it is kind of settling out. Look at that. Huh. I may try to recover it. I probably won't. I just wanted to do this just to see what would happen. And just to see if I could get it to work. And I am just happy that I got some kind of blue shit. I don't know. I guess if it interests you, this is a fairly benign experiment to do. Lanthanum is not really all that toxic. Don't go eating it, but it's pretty benign, as are most of the other things used in this experiment. So, it's something that you could possibly do with your kids. Lanthanum is not very expensive at all. You can buy it on eBay, and it's a fairly reactive metal. Just dissolve it in some vinegar, and that will give you a solution of lanthanum acetate. Just evaporate it down, and bam. You can make the acetic acid concentration stronger. I don't know. I went the roundabout way of dissolving it in HCl first because I was impatient. Anyway, there you go, people. Blue complex of lanthanum acetate. So, if you liked that video, give it a thumbs up. And if you didn't like it, well, oh well. Subscribe, comment, share the video, and until the next one, y'all, I will see you later. That is so fucking cool. Look at that shit.